Hi everybody and welcome to the Callum Cymru revision sessions. The session this evening will focus on Maths and Numeracy Intermediate GCSE and will be presented by Mr John Casey from Pentre Harvard School in Swansea. The session will last around 45 minutes where Mr Casey will run through the relevant content. If you have any questions during the session, please use the question and answer section within this live event and we'll do our best to answer your questions. The session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Callum Cymru tab. Thank you, Mr Casey. Over to you.
Okay, hello all. Okay, so I'm going to be taking you through right-angle trigonometry for about the next 40, maybe 45 minutes. Okay, so let's make a start. Okay, so things we're going to be covering this evening. So 5 bullet points you should be able to see on my slide. So first of all, we're going to label the sides of a right-angle triangle. It is important to understand that when we do right-angle trigonometry, it sounds like an obvious thing to say, but it is only for right-angle triangles. Then we're going to look at the trigonometric functions on a calculator. You may have used these before, or you may not have. If you haven't, you've probably seen the buttons on the calculator, and I'll just show you how to use them and where they are. We're going to be using trigonometry to find the missing length on a right-angle triangle. And after that, we're going to be finding missing angles on a right-angle triangle. And then we're going to do some GCSE questions just to sort of see the sort of questions that you're going to be facing when you do the actual exam. Okay, so I've got some colourful boxes on this slide, and they kind of describe the different sides of a right-angle triangle. And I can't say this enough, it is just for a right-angle triangle, so we couldn't really use this for like a scalene triangle. It has to have a 90-degree angle. So first of all, the hypotenuse. So if you look at my yellow box at the top, so it says the hypotenuse is the longest side of a right-angle triangle, and it's always opposite the right angle. So if you have a look at my diagram, so I've highlighted the hypotenuse in yellow, and it obviously matches the color of the box. Always opposite the right angle, and it's always the longest side. The next one is the opposite side. Now this is important that you understand. Opposite means opposite the angle, either the angle given in the question or the angle that we're trying to find. So you have a look at my little diagram. I've shown you an angle of 50 degrees. So it's going to be the side opposite that, which I've just sort of highlighted in a purpley blue color. So that's the opposite angle. And adjacent is the other one. So adjacent means next to. So adjacent is the one that's next to the angle. Now this is dependent, of course, on where the angle is marked in the diagram. So looking at this picture, my 50-degree angle, as I'm looking at the screen, is in the sort of bottom right of the triangle. If you have a look at this next one, now the angle has moved up to the top of the triangle. So that will kind of change things a little bit. Now the hypotenuse will still be the longest side. That doesn't change. But it will change the position of the opposite side and of the adjacent side. So remember, opposite means opposite the angle. So if we have a look at our angle on the top, opposite that would be the opposite side. And then the adjacent is just the other one, the one left over, if you like. And that's the one that's next to the angle. So if we have a look at these three triangles, we can see whether the angle is marked. What I'd like you to do is just have a go at labeling the sides. So maybe just pause the video for a moment, have a go at labeling the sides with H for hypotenuse, O for opposite, and A for adjacent. And I'll come back on in a second just to run through the answers. Okay, so hopefully you've done that. So let's have a quick look what we've done. So the longer side of number 1 is the one, there's the right angle there in the corner. So the hypotenuse, the longer side, we're going to label with a H just opposite that. I'm looking at the angle here, 41 degrees, and directly opposite that is this side. So that's a bit of a strange looking O there, but that will do. So there's the O for the opposite side, and the adjacent is this one that's next to the angle. Okay, looking at triangle number 2, this side, the hypotenuse is this one here, I'm labeling on the left. Again, opposite the right angle. Opposite is this top side in this case, it's opposite the angle, and adjacent is next to the angle. And then the last one, the hypotenuse, this time is at the bottom of the shape. But if you notice, I've not really given you an angle in degrees, I've given you an X, but the angle is marked. So remember what I said earlier, sometimes we are actually looking to find out what that angle is worth. So the side opposite that would be the opposite side, and then the angle, sorry, the side next to it would be the adjacent side. Okay, so that brings us to the trig ratios. So on our calculator, we've got 3 buttons, which we're going to have a look at in a second. And they're sin, cos, and tan, and they stand for sine, cosine, and tangent. You can see 3 formulas here, sine, cos, and tan formulas. I'll teach you a way to remember them a little bit easier. But basically, sine of x, x being the angle in the question, is the opposite side over hypotenuse. The cos of x is the adjacent over hypotenuse, and the tan of x is opposite over adjacent. And some people remember SOHCAHTOA, so that strange looking word I've got on the screen there, and that's a way of remembering the formulas. What I teach my classes is imagine this old man on a beach there enjoying himself in his old age, and I teach him the little phrase, son on holiday can add happiness to old age. Now I know it sounds a little bit strange, but if you remember that in the exam, and as you're writing it, I tell my pupils to write, I'll probably say this a few times in this session, son on holiday can add happiness to old age. So what I've now got is my 3 formulas, or my formulae, just written there in a little block. The sine one is obviously the first one, opposite over hypotenuse, or O over H in this case. Cos is the next one down, A over H, and then tan is opposite over adjacent. And that kind of sets out my, my formulae, which I need to answer each question. Okay, so the buttons we're going to be using. So you may notice on your scientific calculator, you've got sine, cos, and tan buttons. They're normally in that order, but some calculators are different to others. So, you know, if your calculator isn't like a Casio that's on the screen, you're going to have to get familiar where those buttons are. But those are the buttons we're going to be using throughout the lesson today to find the missing sides, or indeed find the missing angles. Okay, so let's take a look at this example together. We'll do a couple of different examples finding sides, and then we'll move on to the angles a little bit later on. Okay, so looking at this first one, it says find the length of side W. So we can see the bottom of the shape, or you could call it the base of the triangle, is marked with a W. We've got the angle of 37 there at the top. We've also got that side of 15. I think it's worth mentioning at this stage that, you know, you could be tempted to think this is a Pythagoras question. So Pythagoras was the session we did last week. But the reason it's not Pythagoras is because we're given an angle in the question. So in the question, you've got a 37-degree angle there, given to us clearly in the question. So we know it's not Pythagoras. If it was Pythagoras, you'd be given 2 sides and asked to find the 3rd side. But in this case, we've been given 1 side there and the angle. Okay, so I'm not really sure what to use, whether it's sine, cos, or tan. So what I'm going to do is I'm going to write at the side of my page, on the side of my screen, but it would be my page if I was working on paper. So I'm going to write son on holiday can add happiness to old age. And by the end of the video, you'll probably be sick of me saying that, but that's a good way to get those formulas kind of stuck in your head. So let's have a look what we've got. So I'm going to label my sides now. I know that's the hypotenuse, that's the longest side. Here's the angle at the top, so I know this is the opposite side, and I know this is the adjacent. So I've only got really one piece of information for the sides. I've got this 15 centimeters, but this W, you need to think of this W kind of as a bit of information, because that's part of the puzzle. That's what we're trying to find. So which one of these formulas uses the adjacent side and the opposite? And we're looking at this tan formula here. Okay, so tan equals O over A. So I'm going to start with my workings now. So it's going to be the tan of 37. So it's always tan of the angle, or cos of the angle, or sine of the angle. So there's my 37 degrees. You've got to be careful what goes on top. So always on top of A. So always the W, because that's what I'm trying to find. The A is 15. And ultimately, what I need to do is kind of solve this equation to get W on its own, or find the value of W. So what I need to do is get this 15 multiplied by the tan of 37. What I'm actually doing is multiplying both sides by 15, but we can kind of move the 15 up, and we can do 15 times the tan of 37, and that's going to be equal to W. So I'm going to type those numbers into my calculator. W equals, in this case, 11.3 centimeters, and I've rounded that answer to 1 decimal place. I'm just going to put 1 dp just there at the side of my answer. I'm quite fussy with my workings. Normally I keep my equal signs in line, equals on top of each other, but in this case, I've run out of space a little bit, but that's absolutely fine. That would be full marks for the question. Okay, let's move on. Okay, so let's look at this as example 2. I'll go through this a little bit quicker if we're more familiar with the method now. I am going to do my son on holiday can add happiness to old age. So I'm going to put my 3 formulas or my 3 trig ratios there on the right hand side. I'm going to label my sides again. So this is the hypotenuse side. The angle is there this time on the right. So this side over here must be my opposite. And then the other side is the adjacent. So you should be thinking to yourself now, what shall I use? Shall I use sine? Shall I use cos? Or shall I use tan? But if we have a look, we're given the hypotenuse of 19. What are we actually finding? So I need to go back to the question really to find that out. It says find the length of BC. So find the length of BC. So that means from B there in the corner down to C at the bottom. So this is the length that we're finding. Oh, excuse me. So we're finding this bottom. So I could call it BC in my workings, or I could leave it as A in my workings. But what's important is I'm going to use the cos formula. So I'm finding the adjacent side and I'm given the hypotenuse. So I'm going to put the cos of 31 degrees. And that's going to be equal to A is on top. So I'll leave it as A to save right in BC. The adjacent side over the hypotenuse, which is 19. The method is the same as last time. I'm going to multiply both sides by 19. So that 19 goes up to multiply by the cos of 31. So 19 times the cos of 31. And that's going to be the adjacent side I'm looking for. I'm going to put the A over here. I'm cheating a little bit. I'm going to put the A over here equals the answer. And whatever the answer is, when I type all that into the calculator, and that comes up as 16.3 millimeters. And of course, I've rounded that to 1 decimal place. Just worth mentioning really quickly, it's easy to type something incorrectly to a calculator. It's easy to sort of make a mistake or certainly panic or rush in an exam. So I'm going to have a quick look at the question to make sure it all makes sense. It says my hypotenuse is 19. Could my adjacent be 16.3? Yeah, that's a logical answer because I know my hypotenuse must be longer than the adjacent because the longer side. So the numbers kind of fit together. If I had an answer of 32, for example, for the adjacent, I know I've gone wrong somewhere and I've made a mistake. Okay, so last example from me on finding the side, and you probably guess what I'm going to say next. So I'm going to say son on holiday can add happiness, slightly untidy, to old age. And then I'm going to start labeling my sides. So I know that's my hypotenuse. This is my opposite side, this is opposite the angle. This is my adjacent side. So I've labeled those sides. I'm thinking to myself, what do I need to use? Sine, cos, or tan? But it says find the length of DF. So DF, there's D up in the top corner. I'll do that top corner, I've done a little circle on. F is there in the bottom corner. So I'm finding the hypotenuse. So what formula uses the hypotenuse and adjacent as part of the formulas? Hypotenuse and adjacent, that's going to be cos. Okay, so cos of 48, so 48 degrees is the angle in the question, equals, now A here is on top, the adjacent side is on top. Okay, so the adjacent is 12. And the hypotenuse is on the bottom. So DF is the hypotenuse. So that's the side that I'm actually looking for. Now, you may notice this is slightly different to what we did earlier. So the last two examples, the letter we're finding, or the side we're finding, is on top. Now it's on the bottom. So it does change things a little bit. So mathematically, what I need to do is I need to multiply both sides by h and divide both sides by the cos of 48. Now that seems like a lot of work, but for the purpose of this, what we can kind of do is swap these two terms over. This isn't very mathematical, but it certainly does work. So I'm going to swap these two terms over, and this is the way I'm going to write it out. So I'm going to write h is equal to 12, all divided by the cos of 48. Now, you have to be a genius to work it out in your head, but obviously I'm going to use my calculator. So I'm going to type in my calculator 12 divided by the cos of 48. Certainly practice this before the exam because different calculators work in different ways. You may need to put brackets around the cos of 48, maybe, but make sure you are familiar with your calculator before the exam. But when I type that in, that comes out as 17.9 meters this time as our units, and that is to 1 decimal place. Again, does that make sense? Yeah, the adjacent is 12, hypotenuse is longer than 12, it's 17.9, so that does make sense within the context of the question. Okay, so there's 2 questions for you to try, so have a go at them. If you notice, I've written my son on holiday can add happiness to old age. To save me writing that every single time, that's at the side of the screen for you. So have a go at those 2 questions. Maybe pause the video now, and I'll come back in a second just to run through those 2 answers. Okay, so hopefully you had a go at them. I think I'm going to label the sides of both triangles first. So I'm going to call that H for hypotenuse, and O for opposite, and A for adjacent. And while I'm labeling, I think I'll just jump straight to question 2 and label this one as well. This is going to be the hypotenuse. So that's going to be the hypotenuse. The opposite side is going to be this one opposite the angle, and this one's going to be the adjacent. Okay, so let's have a look. What trig function I'm going to use for each question. So is it going to be sine, is it going to be cos, or is it going to be tan? Right, so this one, I'm finding this side I've labeled with a V. So side V, which is the opposite side, and I've been given the hypotenuse. So for this question, I'm going to be using sine. So I'm going to put the sine of 28 degrees, and the sine formula is O on top of H, or O over H. So O is the opposite side, which we've called V in this question, and the hypotenuse is 12. This 12 on the bottom I don't really want, so I'm going to bring that over the other side as a multiply. I'll just go below the question here. So 12 times the sine of 28. If I type that in my calculator, that's going to give me my answer for V, and that comes out as 5.6 centimeters. And of course, that is to 1 decimal place. Again, I'm just going to pop that underneath because I'm running out of space. Okay, this question, I've already labeled the sides because I did it earlier. I'm having a look at what it's asking for. So asking for side P, which I can see is the hypotenuse. It's not asking for A, but I'm given side A, which is the adjacent. So I'm looking at my formulas to think which one of these uses A and H. It's going to be the cos formula. So it's going to be the cos of 43, and that's going to be equal to A is on top this time. So that means 20 is on top, and the hypotenuse is on the bottom of my formula. So that's going to be, I'm going to call that side P. So this is one of these questions where the side we're trying to find is actually underneath, is on the bottom of the fraction, if you like, on the bottom of the divide. So I'm going to swap places with the cos 43 and P. They're going to change over. So it's going to look like P equals 20 divided by the cos of 43. So again, this is purely a job for the calculator. Again, just make sure you know and understand how your calculator works. But after I enter those numbers, I get an answer of 27.3 meters. And again, I rounded that answer to 1 dp. So 1 dp in brackets, as I should always do. And that gives me the answer. Excuse my dodgy looking 2 there. It looks like a 1, but that is a 2. And if I check the sort of the sense of the question, if the adjacent is 20, could the hypotenuse be 27.3? Yes, it could. So it does kind of match with the question. Okay, so we're going to look at now finding angles. So here we got our scientific calculator again. But when we find angles, we need to do the inverse of sine, cos, or tan. So we don't just press those buttons, we have to do something else. So what we need to do is, locate those buttons as earlier, but also the shift button. Now what the shift button does on a calculator is gives us a second function. So if you notice on the calculator, there's little bits of yellow writing, and they show you the second functions. It's quite useful for quite a lot of things. You may have used it in the past to find pi in your calculator, for example. So we press the shift button, and then we press sine, or we press shift and cos, or we press shift and tan. And what that does is on our calculator screen, it gives us that second function, and it will say sine to the -1, cos to the -1, or tan to the -1. So we're going to be using that function to find angles. It might be worth you just sort of checking that out and trying that to make sure you understand how that works on your calculator. As I mentioned earlier, different calculators work in different ways. Okay, so let's take a look at this question. So I've written my son on holiday can add happiness to old age. I've written that already to save us a little bit of time. So I'm looking at the question. I've used a bit of a weird symbol here. It kind of looks like a little Easter egg, but the symbol is theta. So theta is sometimes used in questions. It's letter in the Greek alphabet, but generally it's used for a missing angle. So if we're finding a missing angle, it could be called theta. It doesn't have to be. It could be called X. It could be called K. It could be called any letter really. But for this question, excuse me, for this question, I've used theta. Okay, so I'll go through the steps. So I'm going to label my sides. This is my hypotenuse. Okay, so that's the hypotenuse. There's theta, which is the angle we're looking for. Opposite that is going to be the opposite side. And then the other one, which is next to the angle, is my adjacent. So I'm thinking of my my three functions, sine, cos, and tan. I'm thinking which one of these uses a and h, and a and h is going to be a cos question. So remember I said earlier, you always write cos and then you write the angle. Now in this case, I'm not sure what the angle is, so I'm just going to call it theta. So I'll keep that as theta, and that's going to be equal to cos is a over h. So a is 15 over h, the hypotenuse, which is 18. And that's the first stage of my workings. Now, with this question, we have to kind of get theta on its own. Okay, so what we're actually doing is sort of dividing by cos, but actually we're finding the inverse of cos. And this is where this little button comes in I mentioned earlier. So if I bring cos over the other side of the equation, theta stays on that side. And I'm going to write cos to the -1. So that's the inverse of cos, which is the function we have to use on our calculator to find that angle. Now, it is worth mentioning, I've got quite an old calculator. I've had it for years, so that's why I've still got it. On my calculator, I type in 15 divided by 18, then I press equals, then I do the second function, shift and cos. Some of the newer calculators, you have to press shift and cos, and it gives you the cos to the -1, then type in 15 over 18. But it's really important before the exam that you understand how your calculator works. So please don't leave it till the last minute, or don't rely on borrowing a calculator on the day, because you're not going to understand how the second functions work. So cos to the -1, 15 divided by 18, and it comes up as 33.6. Be careful here, it's not 33.6 centimeters, which is a real common mistake. It's 33.6 degrees. So remember, we found an angle in this question, the angle represented with theta, and again, I rounded that answer to 1 decimal place. Okay, so one more of those examples. Okay, so I've got my my formulas on the right-hand side again. I'm going to label my shape with the hypotenuse, with the opposite, which is down here this time, and the adjacent. I can see straight away I've got no information for the adjacent, so I know I'm going to use sine because that uses opposite and hypotenuse. So I'm going to do sine of the angle. Now this time the question is called the angle G, so I'm going to do the sine of G, and that is going to be equal to the opposite over hypotenuse. So opposite is 17.2, and hypotenuse is 23.6. Now there is always a fear of these questions and mixing these numbers up. So for example, I could have 23.6 on top. I could have kind of messed it up. What will often happen in that situation is your calculator will come back with an error. Like it will tell you that you've made a mistake. So just then double check what you've done and make sure you've labeled your sides correctly. So I'm going to move that sine over. It's going to be sine to the -1. That's going to be 17.2 still, divided by 23.6. So I'm going to put all that information into my calculator, and that's going to give me an angle of 46.8 degrees, rounded to 1 decimal place. Okay, so there's 2 questions on the next slide for you to try. So just pause for a second, have a try those 2 questions, and I'll come in and we'll work through them. So hopefully you've had a chance to try them. I've just put my little trig ratios at the side to help you out. So let's do some labeling. So I'm going to label the hypotenuse straight away on this shape, opposite the right angle. I'm going to label the opposite there at the top, and I'm going to label the adjacent. And while I'm in my labeling mode, I'll do the other one as well. So this is the hypotenuse this time. Opposite n is going to be this one up here, and my adjacent is going to be the other one. Okay, so let's have a look at this first one. So hypotenuse, I've got no information there at all. That's not going to help me with the question, but I've got some information for A and I've got some information for O. A and O is going to be tan, so I'm going to use the tan formula. So tan of the angle, which is angle D, is going to be the opposite side of 5 divided by the adjacent side of 11. Remember, I'm finding the angle, so I'm going to bring this tan over as tan to the minus 1. So remember the inverse of tan. So tan to the minus 1 of 5 over 11. Put that information in my calculator, and it comes out with an angle of 24.4 degrees. And again, rounded to 1 decimal place. This question, I got no information for the opposite side, but I have got some information for the hypotenuse and the adjacent. So I'm looking at the cos formula for this one. Looks good because that uses A and H. So I'm going to put cos of angle N in this case is equal to 13.7 divided by 16.8. Remember, I need to get n on its own. So any equation that you're sort of solving, you want to get the letter on its own, even if it's sort of a normal solving equations question. So I'm getting that on its own, and to do that, I take cos over. So cos to the minus 1 is what it becomes. 13.7 divided by 16.8. And that gives me a value for n, when I put that in the calculator, as 35.4 degrees, rounded to 1 decimal place. Okay, so we're going to talk about some GCSE questions, and we're going to maybe have a go at a few GCSE questions. But before we do that, I'd like you to have a quick look at this slide. So not always, but quite often in the GCSE questions, it will mention something called an angle of elevation, or it will mention something called an angle of depression. So as you can see from the yellow guy on the screen, the black line represents a horizontal line, which is his line of sight. But when he looks up, maybe at the plane in the sky, he's looking up, that becomes the angle of elevation. Or if he's looking down at the cat on the ground, that becomes the angle of depression. In some questions, what you're going to need to do is kind of, take away from 90 or maybe do something with that angle. It's not always going to be the angle in the question is the angle of depression, for example. Okay, so you might have to do a little bit of maths or a bit of working out to sort of find the angle in the triangle that you're looking at. But we'll discuss that on one of the later questions. Okay, so here's a typical GCSE question. So we've kind of gone from just, what we call a procedural question, just with the triangle, to something with a bit of context. As you can see there, the Eiffel Tower. And let's have a quick look at the question that says, and I'll give you an opportunity then to pause the video, have a go before I come back in and discuss the answer. So it shows us the Eiffel Tower and it shows us the height of that in meters. And point P there, which is just the point on the ground, is 800 meters away from the center base of the tower. And it's saying calculate the angle of elevation. So straight away, this term angle of elevation is used to the top of the Eiffel Tower from that point P. So if you could pause the video now, have a little try of that, and I'll come back in and we'll go through it. Okay, so let's have a look. So it's not an obvious right angle triangle, but we can see that the line going straight up there is the opposite side, because it's opposite the angle of elevation P. So we're going to call out the opposite side. The hypotenuse, remember, is always the longer side. Now, there's no right angle marked here. There isn't a right angle marked, but we know that the right angle triangle, the right angle would be at the base of the Eiffel Tower. And we've also got this distance here next to the angle, which is A, which is the adjacent side. So we need to find this angle here. So for the purpose of this question, this angle here, which I'm just marking in red, for the purpose of the question, we can call this angle P. I mean, it is point P there in the corner, but it's not going to hurt if we call this P just for our workings. So we need to find the angle, and we're given the adjacent and the opposite. So we're given A and O. So it's definitely going to be a tan question because that's the formula that uses opposite and adjacent. Tan of the angle, as I mentioned, we're going to call the angle P. That's going to make our workings a bit easier. Remember, whoever's marking your paper, you need to make it as easy for them as possible to understand what you're doing. So we're looking at the opposite side, which is 324 meters, which of course is the height of the tower, divided by the adjacent, which is the ground distance that you are away from the tower if you're looking up. But we're finding the angle here. So we're going to move this tan over. So it's going to be tan to the -1. So tan to the -1, remember the inverse of tan, think about that shift button on your calculator. 324 divided by 800. Again, we're going to put those numbers into our calculator. You could divide maybe and then do shift and tan, depending on how your calculator works. But that comes out to one decimal place. It comes out as 22.0 to one decimal place. So pretty much 22 degrees. But we have rounded it. Done all the other answers to one at DP, so that's why I put the 0.0 in. Okay, another GCSE question for you to look at. Okay, so we'll have a quick read of the question, and I'll give you a minute to have a go. So from the top of a vertical cliff, the angle of depression of a sailing boat is 15 degrees. If the sailing boat is 700 meters from the base of the cliff, calculate the height of the cliff above sea level. What I'm going to do with this question is something slightly different. I'm going to let you pause for a second. But if you are really struggling with the question, I'm going to come back in a few seconds and give you a bit of a hint, and then maybe give you a chance to pause again. So have a look at the question, have a go. You can pause the video now, and I'll come back in a moment. Okay, so if you've done the question, great. But if you are struggling with the question, I'll give you a bit of a sort of hint and tip with this one. So it mentions the angle of depression. Now the angle of depression, imagine we're stood at the top of the cliff looking down at the boat. This 15 degrees here is the angle of depression. So that 15 degrees they mention in the question, that 15 degrees is that angle there, which is not inside the triangle. But we know that dashed line and the cliff face, or the cliff, the front of the cliff, that makes a right angle. So if we do 90 degrees, which is this big right angle, take away 15, gives us this angle inside the triangle, not sure what's going on my pen, of 75 degrees. Okay. So we can see those add to 90. So the angle of depression is relevant to the question, but obviously that angle inside the triangle is 90, take away the 15. So if you didn't get that far before, it might be worth you pausing the video again and giving that question a try, and then I'll come back in a moment. Okay, so hopefully you've had a go at that. So let's do some labeling. So I definitely think this is going to be the hypotenuse. This side here is going to be the opposite because it is opposite the angle. And this side here going straight up, that is going to be the adjacent side, A for adjacent. Now, what some people say to do in a question is, obviously we're going to read the question to find out what it's asking. So saying find the height of the cliff above sea level. So we're actually finding the adjacent. But what some people will tell you is call it something. So for the purpose of our workings, I think we'll call it X. So we'll call this side X, and that's the side that we're trying to find. So X is what we're finding, which is the adjacent. We're given the opposite side. So I'm looking for a formula that uses A and O. So the formula that uses A and O is tan. So it's going to be tan of 75. And you need to be careful here. It's not tan of 15. Remember, 15 is not inside the triangle. So it's tan of 75, and that is equal to the opposite side of 700 divided by the adjacent side, which in this question, remember, we've given it a name, we've called it x. I mean, ultimately, you can call it whatever you want, as long as your workings are clear and it can be understood by who's marking. Now, this is one of these funny questions when the side we're finding is on the bottom. So in this case, what I'm going to have to do is move that x up, move tan 75 down. So x goes up there, 700 stays where it is, and we're dividing 700 by the tan of 75, and that gives us an answer, when we punch it into the calculator, gives us an answer of 187.6 meters, and that's to one decimal place. Remember, the information we found is the height of the cliff. If that's 700 meters, could that be 187? Yeah, the answer makes sense. So it's a logical answer and it fits in with the question. Okay, so I think we'll do one more GCSE question. And this question is this question here, which is a parallelogram. Again, not a typical triangle that you could have been expecting. So we're looking at it thinking this is nothing to do with trigonometry, but it actually is. It is a trig question. But what you've got to do is kind of form a triangle within the question. We'll have a quick read through. The area of the parallelogram is not 60 centimeters squared. It gives us that in the question. Calculate the correct area of the parallelogram and give your answer to an appropriate degree of accuracy. I'm going to do the same thing as I did earlier. I'm going to allow you to pause the video, and then I'm going to come back in and give you a bit of a hint, and then I'll run through the full solution. So you pause the video now, please, and have a try at that. Okay, so hopefully you've done that question now, but if you're struggling, let's give you a bit of a hint. So that line, hopefully you can see now on the screen, that dashed line, does split the shape up into two shapes. Actually, one of them is a right angle triangle, and the other one is actually a right angle trapezium. But that's what it split the shape into. And we need to find the height of the parallelogram before we find the actual area. So what we're actually finding is this height here. I'm going to label it x. Remember, I can call it whatever I want really, but that's logical. And we're only looking at this little triangle for the first part of the question. So if you haven't worked out the final answer, please pause the video now and then try and work it out. Okay, so let's run through the question. So I'm going to do my labels. I'm going to do h for hypotenuse. That's the longest side. This little bottom side here is the adjacent. Remember, the adjacent of just this little triangle here, not the entire side. And then the opposite side is this side here. Now I am trying to find this height, this little dashed line that I've inserted into the question myself. So I'm going to try and find that. So O is certainly part of what I need, and I'm given a hypotenuse. So I'm going to be using a sine function on my calculator. So sine of the angle, which is 58, and that is equal to O on top of H. So O is x over H, which is 6. So this is like one of the first questions we did earlier. I'm going to move that 6, so it multiplies by the sine of 58. All of that is equal to x. I'm putting my x over this side now, cheating a little bit, but move the x over and then multiply 6 by the sine of 58. And that gives me an answer of, it gives me quite a long answer, which I'm not going to chop off. I'll explain why. So 5.088, 289, like so. Now, you may be thinking, why have I put all my answers to one decimal place, and this one he's kept as quite a long answer? Because we're not finished with the question yet, and I tell my classes that if you're going to round an answer, round at the end of the question. So don't round halfway, because let's say, for example, a question is done in 4 stages, and you round your answer every single stage, the answer will become less and less accurate as the question goes on. So we always want to try and round our answers at the end. I mean, the easiest thing to do is leave that long number in your calculator. So leave that in your calculator. And what we're actually finding now is the area of the parallelogram. So you must know your area formulas. And this formula you're not given in the exam. So you've got to know that the area of parallelogram is the area equals the base times the perpendicular height. So the height going straight up. So B times H. So in this question, the base of the shape is 10. Perpendicular height is what we've just found, which is this long number. I'm not going to write it all out, but 5.0 blah blah is that number just above there. And we type that into the calculator, it gives us an answer of 50.9 centimeters squared, and that's to 1 decimal place. Now, it's probably worth mentioning now that some of you may be thinking, well, if that's 6 and that's 10, and it says it's not 60, the question makes no sense. But remember, this 6 here is just the slant inside of the parallelogram. To find the area, it has to be the perpendicular height, the height going straight up. So 10 times our number that we found gives us the exact area of the parallelogram. Okay, so that's it for GCSE questions. We'll skip the last one because we're getting short of time. So let's have a very quick recap of what we've done. I think we're confident now that we can label the size of the triangle with our adjacent, hypotenuse, and opposite. I think we're okay with the trig functions. So we've done some questions on finding the length, some questions on finding the angles, and we've covered a few GCSE questions to see what you're going to be faced with. Okay, we're going to do a quick question to finish as our plenary. And this time it's an isosceles triangle. So before you think this guy's lost the plot and he's changed the rules at the end, that's not the case. You know, we're still gonna think about our right angle triangles, even though this isn't strictly a right angle triangle at the moment. So I'll let you take a look at that, have a go at the question, and like I say to my classes, do something. Okay, so try not to just leave it out. If you can do something, it's certainly better than leaving the question completely. So I'll pause the video now, have a quick look, and then I'll come back in and we'll run through the question. Okay, so let's take a look. So we haven't got a right angle triangle, but we have got an isosceles triangle. So what we're going to imagine is if there was a line going straight up from the center of the base all the way up to the top vertex of the triangle, what it would create is a right angle triangle. In fact, it would create two right angle triangles next to each other. Okay, that should be a little square in the corner. It's gone a little bit off with my pen, but we're looking at this one right angle triangle now. Now, because it's an isosceles triangle, we know this line comes out dead center. So if the base is 15, we can do a half of 15, and we know we're looking at this part being 7.5 centimeters. We know the height going straight up is 18. So of course, the length of this side is 18. We have to find angle X, but actually we're not going to find all of angle X. We're kind of going to find half of angle X, and then we'll use that for answer later. So what have we got? Let's do some labeling. So we've definitely got the hypotenuse. We haven't got the hypotenuse, but there's the hypotenuse. There's the opposite, and there's the adjacent. So we've got some information for the adjacent and some information for the opposite. So that's going to be the tan formula. So I'm going to call this angle something like I did earlier. I'm going to call it X because that's what we traditionally call them. So I'm going to say the tan of X equals the opposite side, which is 7.5, divided by the adjacent side, which is 18. Remember, I'm finding an angle, so that tan needs to go over as tan to the -1. Remember that shift button on your calculator. So 7.5 divided by 18. So I'm going to type that in, and that will give me an angle of 22.6 degrees to 1 decimal place. Now that's only given me the angle X, which isn't the full angle. Of course, what I need to do is realize that K is twice the size of that. So, you know, K is 2X. So what I need to do is multiply this answer by 2 to get the actual answer that I need in the question. So 22.6 times 2 is going to be the angle I need, which is 45.2 degrees. So hopefully that makes sense. Just be aware that it's not always going to be as simple as a right angle triangle given to you in the question. Sometimes the questions are a little bit different, and you may get something like what you can see on the screen now. Okay, that's the end of today's session. Thank you so much for joining us, and back to you, Mrs. Dixon.
Thank you, Mr. Casey. So that's the end of the Maths and Numeracy Intermediate GCSE sessions for this term. Good luck to everybody who's sitting their GCSE exams next month. We did put a link to a form in the chat if you can have a go at filling that in for us. It's a very quick form. We'd really appreciate it. And remember that the Callum Cymru revision sessions will be back next term. So look out for the details on the e-sgol website. Goodbye and good luck.